Section 10-2, Part 2. Describing sequences of reflections and dilations. Rectangle A, B, C, D is the large rectangle, and E, F, G, H is the smaller rectangle. You are given that these two triangles are similar. Same shape, but different size. Describe a sequence of rigid motion followed by a dilation with center 0, 0 that maps A, B, C, D to E, F, G, H. Now, I see that there's no way that I could translate this figure here so that A would correspond to E. If you try to move this figure here, there's no way that once you move it to get to E, that H is paired up with D. There's no way. So I see that it's going to take me reflecting this figure over. If I reflect it over, then I think everything would pair up. In other words, A prime would go with E, D prime would go with H prime, and so forth on. So the first thing I'm going to need to perform is a reflection. Now, my line of reflection is this dotted line that I'm drawing. The name of this line of reflection is x equals to 1, okay? X equals to 1. That's my line of reflection. So if I take the original rectangle and I reflect it over the x equals to 1 line, this would be where my reflected rectangle would be. So I'm going to draw this. I would have A prime here. I would have D prime here. I would have C prime here. And I would have B prime here. Okay? Now, look at it this way. All right? Look at it this way. If A is 1 unit to the right of my line of reflection, A prime is 1 unit to the left of my line of reflection. Okay? So here, C was 1, 2, 3, 4 units to the right of the line of reflection. And C prime should be 4 units to the left. 1, 2, 3, 4. Okay? So I have taken this original A, B, C, D, and I've reflected it over my line of reflection, which was x equals to 1. So now I have this triangle. Now I'm going to draw it in blue because this is my reflected, not triangle, but rectangle. I'm going to draw it in blue where you can see my reflected rectangle. Okay, so there it is. All right, so now, I performed a reflection over the x equals to 1 line of reflection. All right, so I reflected it. Now, I can easily see that I've got to find the scale factor so that it would reduce my larger rectangle to the smaller rectangle, okay? So what I want to do here is to determine the scale factor. The first thing I'm going to need to do is find an ordered pair here of A prime, B prime, C prime, and D prime, okay? So, finding an ordered pair for A prime. All right, A prime has an ordered pair. Remember, this is your y-axis. So, A is up on the y. It's at 1, 2, 3. So, A prime is 0, 3. All right, let's go to B prime. B prime would be 0, 1, 2, 3. 0, negative 3. Okay, C prime would be to the left 1, 2, 3 and down 1, 2, 3, negative 3, negative 3. And then D prime is to the left 1, 2, 3 and up 3, 1, 2, 3. So it'd be negative 3, 3. All right? Now, what we can do also is we can look at what is the distance between E and H. What is the distance between E and H? E and H distance, E to H, is 1, okay? What is the distance from A prime to D prime? From A prime to D prime. Now remember, the original size always goes on the bottom when you're trying to determine your scale factor, the original size. So A prime to D prime would be 1, 2, 3. Okay, your original was 3. I could have counted here. A to D, 1, 2, 3. But look at, once you reflect it, and look at the smaller rectangle. What is the length of EH? Because EH pairs with AD. Looking here, EH, the first and the last, it goes with AD, the first and the last, okay? So here, with EH being 1 and A prime D prime being 3, that is my scale factor of 1/3. That's a way you can determine your scale factor. So to find what pairs up, or the ordered pair for the reduction rectangle, we will multiply each one of these numbers by 1/3, okay? So A goes with E, B pairs with F, C pairs with G, and D pairs with H. All right? So I'm going to take each one of these numbers and multiply them times 1/3. All right? So what's 0 times 1/3? 0. What is 3 times 1/3? Do it to the side. What is 3 times 1/3? Now 3 is over 1. If you multiply straight across, you get 3 times 1 is 3. 1 times 3 is 3, and you get 1. So I get positive 1. All right, multiply each one of these times 1/3. 0 times 1/3 is 0. Now what's negative 3 over 1 times 1/3? Place negative 3 over 1 and multiply straight across. Negative 3 times 1 is negative 3. 1 times 3 is 3. And what's negative 3 divided by 3? I get negative 1, okay? I get negative 1 right there, all right? Now multiplying each one of these times 1/3, I've already done it. Negative 3 times 1/3 would be negative 1. Negative 3 times 1/3 would be negative 1. Multiplying each one of these by 1/3 again. Negative 3 times 1/3 is negative 1. And positive 3 times 1/3 would be positive 1. Okay? So, here you have E is 0, 1. F is 0, negative 1. G would be negative 1, negative 1. H would be to the left, negative 1, up 1. So we do have the correct scale factor of 1/3. All right? So this is a sequence of a reflection. What we talked about to begin with was we took the original rectangle, we reflected it over the line of reflection, x equals to 1. A vertical line you name with just an x equals to 1. Then we had a reduction of 1/3, and we determined the scale factor here. And therefore, this mapping maps rectangle A, B, C, D with E, F, G, H.